Hello friends, in this video we are going to tackle the second principle of counting called the product rule, and we are going to take the concept of that. Imagine that you have again two shops, and the first shop contains let's say a number of jeans, and the second shop on the second floor contains B number of t-shirts. So this is on the first floor and this is on the second floor. Now this time you have a budget of buying two garments, but there is one condition: you have to buy one garment from each of the floors. That means you have to buy one garment from each of the shop. So the condition is buy one from each. Okay, so that means mathematically you have to select one choice from each of the choice sets. So now how many ways can you do the shopping? So basically let's take a small example where you have three jeans, and that means the value of A is 3, and you have 4 t-shirts, so that the example becomes elaborate. So we are just instant getting the values of these variables. A is equal to 3 and B is equal to 4. So now with 3 and 4, how many choices do we have? You have to buy one from each. So basically the choice of buying is actually a pair. Is a pair, I will say capital X comma capital Y. So without any loss of generality, we can say that X comes from the choice set 1, and let's say Y comes from choice set 2. That means you have decided for some reason that you are going to shop from the first shop, that means from the first floor first, and then you are going to go to the second floor. So ideally it would not even matter even if you start with the second floor and come back with the first floor. So basically all you are doing is selecting a pair. So this is what I would like to highlight, that you are making a pair of two things, X and Y, where X you are going to fix once and for all that it is going to come from the choice set 1, and the second element Y is going to come from the choice set 2. So once we have decided this, that means we know that first we have to buy from the 3 jeans first, and then we are going to go to buy to 4 t-shirts later. So let's draw. So here let's say you are shopping for the jeans 1. That means you have decided that you are going to take the jeans 1 and you are not going to select jeans 2 or 3. So in that case, when you have decided to go for jeans 1, now the second element is now you have to buy a t-shirt. How many choices do you have to buy the t-shirt? Once you have decided to go for buying jeans 1, you can forget, and then you say that I have got to select either T1, t-shirt T1, or t-shirt T2 or t-shirt T3. This is when X is equal to J1. Now if you are not buying the jeans J1, that means you could have gone to buy the jeans J2. So how many choices do you have for Y? So Y could be T1 or T2 or T3. There is 4 t-shirt also. So when you are buying the jeans J2, the same thing is going to happen, nothing else. You still have 4 choices to buy the t-shirts. So whether you buy J1 or you buy jeans J2 or you buy jeans J3, you basically still have 4 choices. This is called the choice tree. What does this say? When you have decided, this first shows you all pairs of the form J1 comma Y. The second tells you all pairs of the form J2 comma Y, and the third one tells you all pairs of the form J3 comma Y. So now Y is unknown, and how many choices do you have for Y? You have exactly 4 choices for Y. So at the end, all you know that you are going to buy either jeans J1 or jeans J2 or jeans J3. So now, and you have to buy, because you have to buy at least one jeans and exactly one jeans. So because of these wordings, you know that now addition principle should be in effect. So when you have these conditions with you, x is equal to j1 and y could be any one of these things, you are going to solve three problems. When you are supposed to buy only jeans j1, how many choices do you have for the t-shirts? The number of choices is equal to 4. When you are saying that I'm going to buy the jeans j2, how many choices do you have for the t-shirts? Again 4, because no matter what jeans have you selected, it is not going to hamper anything about the choice about the t-shirts. The same thing about jeans J3. How many choices do you have for to buy t-shirts? Is 4. Now all of these numbers come together under the sum rule, equal to 4 plus 4 plus 4, which could be equally written as 3 into 4. So the answer 4 plus 4 plus 4, writing it in the way 3 into 4 is the most important way to summarize the, calculating the answer of this kind of question, is because independent of what jeans you bought, the choice set of having to buy a t-shirt has nothing to do with that. So basically the answer is equal to choice set C1 into choice set C2. We could immediately generalize this, that let's say you have the choice set C1, C2, C3 up to, let's say, n choice sets, and you are going to buy one from each. So select one from each. So when you select from one from each, that means you have to necessarily select. You don't really have choice. You have to select. So in that case, the answer would be, that means the number of ways to pick up x1 comma x2 up to xn. This time you are going to select n objects because you are going to select one from each. So let's say small x1 is an object that you have selected from choice set 1, small x2 is an object that you have selected from choice set 2, up to small xn is an object that you have selected from choice set n. So this time, instead of selecting a pair, you are selecting an n-dimensional vector. So you could say n-dimensional vector. So the question relevantly that should be asked is, under these conditions, how many such n-dimensional vectors exist? And the answer is size of the choice set 1 into size of the choice set 2 up to, that means the grand multiplication of the sizes of each set. This could be summarized equally as the running product 1 to n of choice set I. And the explanation behind the generalized product rule is exactly same as the generalized addition rule. Before multiplying three numbers, you have to just multiply two numbers first, and then you are going to do this repeatedly. So the logic behind the multiplication is really the repeated addition. So we know that 15 could be written as 5 plus 5 plus 5. So instead of writing it as 5 plus 5 plus 5, we write it as 3 into 5 to say that we had 3 choices from the first set and we had 5 choices from the second set. So what are the conditions? Conditions need to be observed. In a question, for product rule, PR is the product rule, so we could equally write it here. PR is the product rule, SR is the sum rule. So what are the conditions that need to be observed in a question for PR rule to be applicable? So the first is simultaneity. That means simultaneous selections. The second is independence among selections. We'll look at them. Independence among selections. Now what do you mean by simultaneous selections? When you had choice set C1 which contains some choices, and we had choice set C2 which contains some number of choices. Simultaneous means You have to select one from each at the same time. So we want necessarily one from each. So whether you select it from choice set 1 first, then go for selecting choice set 2, or you start with choice set 2 first and then go for selection from the choice set 1, it doesn't really matter. Or you could say that there are two people who are selecting from C1 and C2 at the same time. So it could be simultaneous or it could be in procedure one after the other. It doesn't really matter. You want one from each necessarily. So the necessity is the simultaneous selection part. Now what do you mean by independence among the selections? So we could again take the same thing, same example. You had small G1, J1 genes, J2 the second genes, the third genes, and T you have, let's say, 4 t-shirts, again from the example. Now independent of what genes you selected, you had the same choice for all the t-shirts. Now there was no competition or no restriction as to say that if I select these genes, then such kind of t-shirt I will not go for selection at all. So there is no dependence among the kind of connection between the two objects. So X and Y, when you are selecting X and Y, X has nothing to do with Y. And this is vice versa also. So X and Y, X has nothing to do with Y, Y also has nothing to do with X, because you could have started with Y and ended with X also, because just like we said that we are once and for all, we are going to fix which choice set we are going to start with. So even if it's the first choice set or the last choice set, there is something called the first, second, third, like that. So independent of the order which you selected at which point of time has nothing to do with what happened in the history, will have nothing to do with what is going to happen in the future also. The third thing, not required, is mutually disjoint sets. Now mutually disjoint sets, that means the mutually disjoint choice sets, they are not really required. That is to say, that really doesn't matter. Now why is it so? Let's say G1 contains small G1, the first garment of the first shop, second garment of the first shop, third garment of the first shop, and let's say fourth garment of the first shop. G2 contains, say, 5 of them. Now say, for example, G13 is equal to G22. What do you mean by that? That means the third garment in the first shop, whether it is t-shirt or jeans or some trouser or shirt, whatever it is, the third garment in the first shop is exactly same as the second garment in the second shop. In all the respect, they are exactly same. So that means both the choices have something in common as far as you are considered. According to shops, they are really different, but for you, it is one and the same thing. The prices are same, the dimensions are same, the utility is same. So for you as a customer, these two garments are not really different. How does it matter here? You are going to select one from each. So this time, when you are going to select one from each, if you have selected the third garment from the first and the second garment from the second shop, is also a legitimate shopping pattern for you. It just the case that for you it is one and the same thing, the same garment has been copied, I mean you bought it twice. So but from that perspective it is okay for your perspective, but mathematically this is also allowed, because selection of G13 from the first has nothing to do with the selection of G22 from the second, because of the independence. So you are going to write it explicitly here. So that's the everything about this product rule. What conditions you need to observe: simultaneity, simultaneous selections, independence among selections, third, mutually disjoint is not really, a concern. So whether the sets are mutually disjoint or not, that's not really a problem. Thank you so much for watching the video. Stay tuned with Ekeeda and subscribe to the channel Ekeeda.